everybody. Okay, so like every lecture, here is a quick remember of what we covered already, and the topics that you need to feel comfortable with. What is your name? I think I didn't.
Ow.
You were in the first lecture. So this is what we covered so far, and today we're going to talk about one of the things that makes Python superpowers, I call it. I'm not the only one who calls it this way. We're going to talk about modules. So, did any of you hear about modules before, and do you know what it is? Anyone? I know some of you already have experience in Python. No? Okay, so what are modules? Modules are files which contain code. Okay, it's a file. A module is a file that contains code, and it can contain anything: a class, a variable. It can contain a function. It can contain executable code. Okay, and one of the things that makes Python superpowers is the fact that you can import modules. You can basically import the power of this module, of this file that is defined somewhere else, okay, into your code and use the power of this file, okay? So it's a bit abstract, but I will of course give many examples today. We're going to focus on this today. And there are basically three types of modules in Python. Okay, there are modules that you can write. This is what we will start with. We will start by writing your own module and see how it works. Okay, so this is one way to use the superpowers of modules. The other way is what we call the standard library. So when you install Python, it already comes with tons of modules which have already been written and optimized and tested by others, and you can basically import these pre-existing modules and use their powers. Okay, so this is what we call the standard library. It's the set of modules that come with Python, and you don't have to reinvent the wheel and to rewrite them from scratches. So I will give you several examples. And then there are libraries. For example, the NumPy library. I will start today with the NumPy library, which are they are not part of the standard library because you need to actively install it in order to use the superpowers of NumPy. But they are very common. They are very well known. They are written in C. They have already been optimized, and basically Python by itself would be actually hard to use if we didn't have all these additional libraries that you can use. Okay, so NumPy, it's adding an array language. Okay, everything that has to do with dealing with arrays, we will use NumPy. You could in principle use lists, but it's less efficient, and you will never do it this way. If you want to use arrays, you import NumPy. I met the guys who programmed NumPy. They're in Berkeley. It's constantly optimized and elaborated, and there are people who work full time in writing these Python libraries that we can import. And perhaps one last bullet point, which I didn't put here, is that one of the beauties of Python and the fact that it's used by so many people, by such a large community, is that people from all kinds of scientific community write their own library. So for example, in astrophysics, I'm doing astrophysics, there is a big library called AstroPy, to which you can contribute, everybody can contribute, and it's already, hi Anna, it's already doing many of the tasks that we need on our everyday life for astrophysics. For example, if you want to convert certain units that are commonly used in astrophysics, there is already a library that does this for you, and you can import it and you can contribute to it. And many fields in science have their own Python library, which scientists or people constantly contribute to. And this is also one of the beauties of Python. There are libraries of machine learning, there are libraries of biology, all kind of stuff which I'm not so aware of, but if you're doing research in a specific field, there is a very high chance that some people in your community already wrote very useful library that you can simply import. Okay? So, I gave this overview of all the different kind of modules that we can import. And we will start with the first one just by writing your own module. Anat, I just say very quickly, I talk about the fact that one of the Python superpowers is that we can write code in different files called modules, and we can import them in our code and use their powers in our code. And there are 3 different ways of doing it, and we will go through each way and give examples and practice. Okay, so let's start with the first one, which is writing our own module. In a second, I will leave the presentation and we will practice and give it a try together. So, what you will need to do is create a file called my first module, or however you want to call it, .py, okay? And then we will write something in this file. We will start by writing hello world, then we will just define a function. We will see how we import it, okay? And then from your main code, you will do import my first module, and you will basically import the power of whatever is written in this file. I'll give an example, but you can already open in the same directory as your main code something called my first module, okay? And then we will talk about where the module should live so that we can import them. Okay, one way is to put them in the same directory as our code, but sometime you will want to write a module that you can reuse in all of your code, and you don't want to copy it every time in the directory where you're coding. So we will see how to do this. Okay, so let's leave the presentation. And today I really encourage you to try to do it at the same time as I do it. Okay, so this is my main code. It's called fourth lecture, okay? And in the same directory, I'm creating a Python code called my first module. Okay, and this is my first module, and in this file you can write any command you want. Okay, so I started by writing simply a print command, which this is a command from the file my first module. Okay, Make sense until now? Okay. Now let's go to the main code and see what happens when I do import my first module. Okay? What will happen if I run this code?
Nothing.
So David says nothing. Other ideas? Error. Aaron says an error. Let's do it. So what we see here is that the moment I do import my first module, Python runs whatever is in my first module. You see? So it's printed here. It's printed here, the command that I put in my first module. Okay, so this is an important take. The import command basically executes whatever is in your module. Okay?
זה רץ על מה שיש בתוך ה...
כשאתה כותב import my first module, זה מריץ את זה. אוקיי?
כאילו, זה לא מריץ כאן כלום.
זה מריץ, תראה. If I run it, זה מריץ את מה שכתוב ב-my first module. ב-my first module, מה יש? יש לנו קומנט. סליחה. יש לנו כמה דברים, אבל אחד הדברים שיש זה פרינט. מה שמתי פה? אוקיי. כולם הבינו? Is it clear? It's very important. Now, if I moved, you have to trust me, and I encourage you to try it. But if I move my first module, let's try it, outside of the directory, it will complain. Let's try it. Okay, so what I'm doing now is to move my first module. I'm going to create a move my first module into move. Okay, so now I've moved, you see, I've moved the module, my first module, into a different directory. And let's see what will happen now. Why is it doing this? It's because it's importing post lecture. Okay, it's still running it because I built the thing in a certain way that it will. I'll talk in a second about why it's still doing it. But because you didn't define your Python path in the same way I did, if you move, I encourage you to try it. If you move your module outside of the directory where you are importing it, it will complain. It will print an error. Okay? Okay, let's move it back. לא טעות. אם תזיז את זה לדסקטופ למשל, אם תזיז את זה למקום שהוא, if you move your module to a different directory, not the directory where you're running your code, it will complain. Okay? Okay. Okay, now the important thing in my first module, you can do I'm now defining a new module called my second module, okay? And in this file, I'm printing, I imported my second module, and I'm doing other things. I'm defining a variable called test string, okay? And I'm also defining a function, okay? And now we will see how we can, what happened when we do import my second module, how can we use both this variable and this function that we define in the module. Okay? So let's do it. So I'm doing now import, it's writing in Hebrew, my second module. Okay, and now I want to use, well, first I want to use to access the variable test that has been defined in my second module. Okay, so print my second module test. Okay, so now let's run it. Okay, so I import my second module. What is it doing? It's printing, it's executing it. Okay, so it's printing, I imported my second module. Okay, and then if I want to access the variable from the file called my second module, the way to do it is with this syntax, where I use my second module, point, and the variable. Raz and Odelia, it makes sense? Okay? Good. So we learned how to access a variable which is defined in a module. Now let's see how to access a function that is defined in a module. So let's have a look. In my second module, I'm defining a function that is looking for the index of a list, of a sequence. Okay? So I have a sequence of courses, and I want to ask what is the index of math or physics. Okay? So this function, this is what it's doing. And now I want to use this function in my main code. Okay, so let's see. So I'm defining a sequence of courses. Okay, and I want to ask what is the index of math. And I don't want, let's assume that I need to use this functionality in many codes. I don't want to rewrite the function everywhere. I want to have a library of things that I'm using all the time. Okay, so I defined a module that does this functionality, and I now want to call this function. So the syntax I'm using is this, my second module, point, and the name of the function. Okay? Make sense? So let's try it. Okay, so it's telling me that the index of math is 1. Is it true? Yes, it's true. Okay? So we learned how to import a specific variable and how to import a specific function from a module, right? Good. I'm being slow here because it's very, very important to understand how this module things works, because we will use it all the time. Okay, so there is a way to make the name of the module shorter, which we will use a lot. Yes. So let's say I assume that I want to shorten this, so I can do this, for example. Okay, and then the moment I do import my second module as whatever name I want to give it, it will not recognize this name anymore. It will expect that I always use the name by which I've imported it. Okay? So let's see if it's working. Yes, it's working. And you will see it a lot. So when we import NumPy, we never write NumPy, we write import NumPy as NP. Import pandas as PD. Okay? Yes.
מה זה אומר האינדקס שווה מאוד נקודה 2? שורה לפני הסוף.
כן, אז בדיוק היית בחוץ. We talked about, so Anat is asking what this means. Okay? So I want to be able to access a specific function which is called find index, which is defined where in the module called my second module. So if I only used find index, it will not know. I can have, like, I'll give you an example. In my library, I have many different files where I define the function called find. Okay? And so it will want to know which function you want. So the way to access this is by writing mod. This is telling it to go to the file called my second module, and then to look for a function called find index and use this specific function. And you can try to define a function called find index in a different module, and to see that if you don't call the correct module here, it will not work. Okay?
Yeah.
Good. So we saw how to import a variable, how to import a specific function from a module, how to make the name of the module shorter, okay. Now let's assume that I want to import. I don't want to import everything from the module. I want to import only the function. Okay, so one way to do it is to write from my second module import find index. Okay, if I do this, I don't have to use this anymore. Okay? If I explicitly tell it from my second module import this function, I don't have to tell it that it's in this specific module anymore. Let's give it a try. It's working. But I still need to, if I try it with test, for example, it will complain, right? It will tell me test is not defined. So what is the way to solve this? Is either to write from my second module import test, right? And then it will not need me to write mod.test anymore. And the other way is to point it to the module specifically. Okay, if I write this, it will work. Okay, and if I do from my second module import test, it will also work. Okay?
מה זה הטסט?
Test is a variable that I defined in my second module.
אוקיי.
But it still also runs the module, right?
Yes, but it runs the module, but if I want to access, it runs the module, but it will not give you access to the variable or to the function unless you do one of two things. Either you specifically import the variable, okay, and then you can use the variable without any reminder of the name of the module, or you will have to explicitly say that you want the test variable from the module mode. You understand, David?
Yes.
And the reason it's built this way is that if you import, you will see, like in your code, usually you will have a list of, 20 imports at the beginning. And if the test variable has been defined in more than one of these modules, Python wants you to explicitly say where you want to import this variable from. Okay? Make sense?
Yes.
Other questions? Okay. And you can also shorten, sorry, you had a question. Okay, we said how we can shorten the name my first module, right? My second module. So the module name, we can also shorten the name of the functions. Okay, for example, if I want to import find index, but I find the name of the function too long, so I will import it as fi, and then here I refer to it as fi. Okay? So this is also an important one. Okay, there is something that people sometimes do, which it's not only me. It's really bad practice, but I will still tell you about it. You can do from my second module import star. What this means is that
It imports everything, right?
you import everything, and then you never have to specify the name of the module where you imported it from. Let's run it, see it works, it works. But why is this bad practice?
Be slow.
Hmm?
The program will be slower.
And I don't think it makes it much slower.
You aren't sure where everything is coming from, especially with multiple libraries.
Exactly. So the moment you do this, if I did from my first module import everything, I don't know where this came from. Okay? And it's very important to know where this function came from, especially if you define the function with a similar name or the same way name in your main code. Okay? It can lead to many errors. So I never recommend to use this, but just you should be aware that this line you can do it. Yes.
מה הכוונה מאיפה יגיע? כאילו הרי עשית מודול אחד.
כן, אבל okay, so Anat is asking what do we mean by not knowing where it came from? Let's assume that okay, I did two modules, okay?
Mm-hmm.
And here in my function I also defined all kind of find okay, and let's say assume that my code is 1,000 lines long, so I don't remember exactly how many functions like this I defined, and I have here 20 lines of importing, and I don't remember, each of the modules here has hundreds of lines. I don't remember exactly what I did in each of them, okay? And so here, if I do this with the stars, it will work, but it doesn't tell me in which module this function has been defined.
Okay.
Okay? So this is the reason to avoid this comment. And it makes it harder to track bugs and problems. Okay, now how does Python know where to look for the modules? Okay, we started with the very simple case where I defined the module in the same directory as my code. But imagine a situation where you have an architecture with many directories, many subdirectories, and as I said, you want to be able to use a module for all the codes that you write in all the subdirectories, and you don't want to copy the module in each of the directories. It's also an issue if you want to change the module, you want all your codes to inherit from the change you did in the module. So how do you tell Python to look for your modules in a specific directory? Okay, and this question is also related to where does Python, by default, where does it look for your modules? Okay, so here I will use a code that is from a module from the standard library called sys. Okay, so sys is a module that comes, it's from the standard library, it comes with the Python installation. When you install Python, we will see in a minute where it's installed, where the standard library lives. But sys is a module that comes by default with Python. And if I do sys.path, let's see what it does. Okay, so it's running my second module. It's executing it because I did import, and then I import this, and I told it to import to print syspath. So syspath it's a list. You see what I'm having here? It's a list of paths. Are you familiar with the concept of a path? A path is a location in my computer. And all these are directories. Okay, so this is a directory called user. Under this directory, there is a subdirectory. It's called מעיין, then faculty, teaching, da 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 da. Okay, so what is this telling me? This is giving me the list of all the places where Python will be looking for modules, and it's in order of priorities. Okay, so what it does is that it first look into this directory, which is what? It's the actual directory where I am, where my code is. Okay? Then it will go one directory back. Okay? So you see that now I'm in a directory called 2025, so it will go one back. This is why when I moved, I tried to show you by moving my first module back, it was still finding it. Why? Because Python is looking also one directory back, okay? And then there are all kind of other paths where it's looking for modules, okay? A long list. Now, it's very important to be able to visualize this, because this will help us understand where we need to put our modules if we want Python to find them. Okay? And if you're importing something and Python complains that it doesn't exist, you can print syspath, and it tells you exactly where is Python looking for your module, for the module you're looking for. Okay? Now, you see that, okay, is Python looking into my desktop? No. You see that desktop is not in any of these locations. Okay, so this tells me how to move, how to show you what happens when the module is not at the correct location. So let's try. Okay, let's give it a try. So I'm moving my first module into the desktop. Okay, and now let's see what happens when I call a module that is not in any of the directories that is in the path. Why is it still working? This is very weird. I'm not sure why it's still finding it. So I will have to check this.
You have to import it again.
It's importing my first module,
To run it.
but this should not be here anymore. Maybe there is something called my first right, because there is another one called my first module in okay, let's try. I want to show you this. Okay, move my first module desktop. Okay, I've renamed it, and now I will try to import the code called my first module, which is on the desktop. Okay, what I'm trying to show you here is what happened if you're calling a module that is not in any of the paths that is defined in your Python path. Okay? Good, I managed. So it's complaining. It's telling you there is no module.
You also put it in itself. You put that first module in the first module file.
No, but this is why I changed the name. Okay, because in the previous year I put it in a different location. So this is I'm doing it from scratch. I'm putting a module called my first module desktop on my desktop. Okay, and I'm calling it from here, from a location that is not the desktop. Now it's complaining. If I wrote this very same code on the desktop, it would find it. Okay? Make sense?
Yeah.
Good. So let's put it back. Okay, and now first module, I want to move it into move it back. Move my first I'm moving it back so that we can use it. Okay, now let's see that it's working. Right. Muy good. Okay, so we saw what happens if the module is not in the location where Python is looking for it. Okay, and now there are two approaches on how to tell Python to look at a specific location. Okay, there are two ways. So the first way is to use this list and to edit this list. Okay, so I'm writing now a module on the desktop, okay, called my desktop module.py, and I write here print, this is my desktop module, okay? Okay, so I'm going to try to call this this module here. Will it complain?
Yes.
Why?
Because it's not connected to the sys path.
Exactly. So what I can do is to append. There is a command called append. When I'm appending, I'm adding. Sorry about this noise. I don't know why it's doing it. So I'm appending here the path to my desktop users. מעיין, סומנייק, desktop. Okay. So let's first see if it added it to the sys path. Okay, so now you see that it's added at the name of this list of paths the desktop path, which means that it will also be looking for modules on the desktop. Okay, and now let's do import my desktop module. Okay, and you see that now it's working. It's writing this is my desktop module, so it's going. Python is looking in the desktop for a module called my desktop module, and it's finding it. Okay, but if I put this line before adding the path to the Python path, it complains. You see? So this is one approach, is to change manually the sys.path. Another approach, which I personally prefer, is because you don't have to do it from inside the code. Okay, who has Windows here, and who has Mac or Linux? Who has Mac or Linux? You're with Mac and Linux, and David, Windows, you too? Okay, so both in Windows and Mac and Linux there is something called the terminal. Did you ever use it? You used the terminal before, Shahar? Yes? Okay. So, and David, did you use it, the terminal?
Not today.
So in Mac or Linux, basically in Mac things are very similar to Linux. You can access something that is called the Python path. Python path. Okay, and this is doing the same as sys.path. If you do echo Python path here, you see, it will do the same as sys.path. It actually, I see that here that it's this is another reason to use it. So if you print Python path, it will go and show you all the places where it's looking for modules. Okay, and then somewhere in your computer, I don't know in Windows which file, what's the name of the file, but in Linux and Mac, it's called bash, either bash RC. Did you ever try to visualize the bash RC? Or in my computer, it's called ZSHRC.
What is that?
So there is a variable in your computer called the Python path, where it has the list of paths where it's looking for modules, for Python modules. And you can basically edit this variable from a file that you will have to figure out in your computer what it's called, but usually by default it's called bash RC or bash profile, like .bash RC or .bash profile. Okay, I gave it a different name, but I show you what it looks like. Okay, Python path. So here I've added to this variable all the places where I want Python to look for modules. Okay? And so in our case, I could have added desktop in this list. And if I add desktop in this list, I don't have ever to append the desktop from within the code in the sys.path. You see what I mean? So the moment I open my computer, the moment I run Python, it will add this path to the Python path and know that it needs to look for modules in this path. So I will ask the tutors to try to show you where your Python path is defined in Windows 2, so that you can easily edit it and then tells Python to look for modules in various places. Okay? Good. And you can also ask Google by doing Python path window. You can ask it, where is my Python path defined? Okay? And this is something I'd like you guys to check as an assignment. Where is your Python path defined and how to edit it? Okay? Good. Okay, so let's go back to the presentation. Okay, so we ask where the modules live and how will Python look for them. Okay, so it can either be in the directory where you're writing or in another directory, which is defined, which is given in your sys.path command. And you can edit the location where Python is looking for modules. Either you can do it from within your code by using this command, or, and this is much better, you can edit your Python path and then you don't have to redo it from within the code. Okay? Good. Now, I said that we have three categories of modules. So there are the modules that you will be defining for yourself, for your own purposes. And there is a bunch of modules that comes with Python, which is called the standard library. And I will now give you a few examples. And I don't know all of the modules of the standard library. It's a huge amount, and depending on your needs, you will be exposed to certain modules more than other. And it's very good to know more or less for your own needs what has already been invented in Python, so you don't have to reinvent very basic things. So I will now give you a few examples of modules that come with the standard library and which are very, very useful. Okay, so let's give you some examples. And then after this, we will do the break and we'll talk about the NumPy library after. Okay, so let's do it. Okay, so there is a library. This is NumPy. Okay, let's say I want to grab a random value from a sequence. Okay, so I will do my usual course list.
השורה מעל את רצית כאילו להכניס מודול שקוראים דסקטופ?
רציתי לשים את
דסקטופ במקומות שהיא יכולה לחפש מודולים.
רציתי לשים מודול שלי בדסקטופ שלי, ורציתי להגיד לפייתון שיחפש גם בדסקטופ, ולא רק בדירקטורי שאני נמצאת בו. בעצם אמרתי לפייתון, תחפש, גם דסקטופ הוא אזור שאתה צריך לחפש בו מודולים. בסדר? Okay. So let's assume that I want to grab a random value from this sequence. Okay? Okay, so I import, there is a directory called a module called random in Python. Usually, I will tell you that usually we do all the imports. The good practice is to do all the imports in the beginning and not within the code in the location where you need it. Okay? So, I want to grab a random value, so I do print random dot choice course. Okay, and now I want to do it again to show you that it's doing it randomly. Let's do it. Why is it complaining? Why is it complaining? It's telling me that this function does not exist in the module random, and it's correct because I put an S here. Okay? Okay, so you see that I've used the same command 3 times, and it's giving me a different course every time. So it's basically this module from the standard library picks a random guy here and just print it and return it. Okay? So this is a very useful one. Can be useful. Now, another very useful one. There is a module in the standard library called math. Okay, I don't want to have to redefine pi every time. So there is a module called math where many of the basic stuff of math related basic stuff have already been defined. Okay, so printing pi. But so pi is very basic, but there are other things that are also basics. For example, converting between radians and degrees, or all the functions, all the very basic math functions like cosine, sine, okay? These have already been defined in the math module, and you don't have to redefine it every time. So let's check, let's try. Okay, so I want to convert 90 degrees into radians. Print rads. Okay, so radians is converting, it's a function that converts a value in degree into a value in radians. You don't have to reinvent the wheel. And not only has it been written already, but it's also been optimized. So many of the modules in Python are written in C. If someone tells you that Python is slower than C, it's true, but many of the Python modules or Python libraries have been written in C. So Python is basically inheriting of many of the benefits of C. Okay? Let's try the sine function. So what is the sinus of 90 degrees? It's 1.
Can it also do like integral or derivative?
Very good question. So the answer is yes, but not as part of the math module. There is a module called I think, okay? I would probably ask, in this case, I would probably ask Google what's the best way to do an integral with Python. But there is a library called SciPy, which is not the standard one in the sense, what does it mean that it's not the standard one? It's not installed by default the moment you install Python. Okay, when you install Python, it installs the math library, but it doesn't install SciPy or NumPy. And I think SciPy would be the library to use for integrals. Okay. Okay. There is another very useful module from the standard library, which has been installed without you even knowing it. It's called datetime, and another one called calendar. And this is doing all kind of manipulations that have to do with dates and okay. So for example, if you want to add 35 days to today's date, and you want it to tell you what will be the date of that day, for example. Okay, so let's check. Let's try what it's doing. So I'm defining something called today, and it will give me the date of today, hopefully. Okay, is that correct? Yes, it's correct. Okay. Let's say I want to ask it if a certain year is a leap year or not. Shana, how do you say leap year? מעוברת. Okay, so there is a function called isLeap, and let's give it several cases, right? So 2017 was not a leap year, but 2016 and 2020 were. Okay. Now I'm giving you just a very, very little insight into what these libraries do. Okay, but it's important to realize that the moment you installed Python, you also installed a ton of modules that already know how to do very basic and useful stuff that you don't have to rewrite and reinvent. Okay. Let's give another example. There is a library called a module, called OS, import OS. Okay, and so OS, it's giving you access to the underlying operating system. I'll show you an example. So if I want to know in which directory I'm located, okay, so I would print os.get current directory. Okay, and so it's telling me this is the directory where I'm located. Okay, you can remove code, create files from within your Python file thanks to this library. Okay, if I want to do os remove directory, I want to remove the 2025 directory. I'm not going to do it because it will remove everything, but I can do it from within a code. Okay, so OS is very useful. It's giving you access to all the system of directories and files outside of your code.
If you do it, well, like Max in it, can you control Z?
No. But you can change file, you can do all kind of files. Okay, now I want us to explore where is the standard library located. Okay, so you remembered we printed the sys.path to tell us where it's looking, but I want to do better. I want to know where is it looking for when I'm calling math, when I'm calling OS, when I'm calling date time. Okay, where is the standard library? So the way to do it is the following way. OS. I think this is the way to do it. Okay. So it's telling me that the OS module, okay, OS is a module, it's a file, it's a Python file that has been written somewhere when I installed Python. So it's telling me that OS is in this location. Okay, so let's go to this location and see if we recognize stuff from the standard library. And on your laptop it will be somewhere else, okay? Obviously. So let's do okay, so I used the terminal to go to this location that it's printed, and let's see if I'm recognizing things here. Okay, so OS is here. You see? Let's see if I find random that I used before.
What are the ones in red?
Okay, random is here.
No, in red.
I don't know. That's the answer. It's some way that my terminal color, it's a color code of my terminal. So the bold ones are directories. Maybe these are stuff, some permissions. I'm not sure why are the red things. But these are directories, the bold ones. And you see that, okay, so the random, you remember I used the random function, the random module? So it's here. This is where a lot of the standard library is stored. Okay?
Maya,
Yes.
can you access the internet if you have like...
If I have what?
Can you access like internet if you have HTTP, HTML?
This?
Yes, can I import from a website?
I don't know what is what is, let's see. So these are all modules, and I don't know what they're doing. We will have to research this. But let's have a look at the random one. Okay, so this is the random code. You see, it's very long. What did we use? We used the function called choice. Okay, let's see if we find it. Okay, this is the function. Remember that we defined in the beginning of the lecture today, find index. So it's working the same. There is a function in the random module called choice, okay? And it's telling us it's choosing a random element from a non-empty sequence. You have access to all the underlying library. It's pretty amazing how it's working. It's very transparent. And I'm not sure you can edit it, but it would be worth trying. If I edit here, print this, I'm now running choice from the, okay? So this is pretty cool, and you see that there are many functions that I didn't show you. So there is a function called shuffle, which is doing other stuff, okay? So these are Python programmers who already programmed the functions for you. Okay, I'm going to show you two more things before we continue. So there is a function very useful called time, which is a module, very useful module called time, which times things in your code. Okay, this can be very useful when you do profiling. You want to know what are the parts of your code that takes most time. Okay, so you do the following: start time, and then let's print. Here is a piece of code. I want to know how long it takes to run, okay? And I'm going to do a very long loop because if I only do a print command, it will take microseconds. So for I and I want it to define a variable. How many times? 1, 2, 3, 4, 5, 6, 1 million times. I want it to define the A variable 1 million times and to print done at the end. No, I don't want it to print done 1 million times, just at the end. And then I want it to end, and I want it to tell me how long it took to run the code. So maybe we'll start with 1,000 because I'm worried that it will take too long. Okay?
וכאילו נותן לך את הזמן שרק לוקח לתוכנה לרוץ?
Exactly. So it's defining, so the time module, I don't know so it's defining a time, it's not in seconds, it's it's in seconds, but the 0 is a weird choice, but it tells you how long has passed between start and end. Okay, you see? This is the way to profile your code. So 1,000 times it took 80 microseconds. Let's do it 1 million times. Nine complaints.
לפעולה קוראים time נקודת time?
כן.
Yes. Okay, so it took 60 milliseconds to run the loop 1 million times. Okay? And you don't have to reinvent a way to time things. Python already did it for you. Okay? And if you want to know how it works, Python is being transparent with you. You can go to the location of the standard library and just look at how it's been defined. Okay, now you see that there is, we'll do one last thing. You see that there is a module here in the standard library called anti-gravity. Okay, so I'm curious to know what it's doing. So let's look at what's inside and try to guess what it's doing, and then we will run it. So, okay, so it's telling me it's going to it's using a module called web browser, which we can guess what it's doing. Okay, it's browsing from the web, and it's going to this address. Okay, and it also has a function that is doing this, but this we will not use. But let's see what do you think will happen if I import anti-gravity? What will happen? It will execute this, right? So it will basically open a web page. You agree? Okay, so let's try. Anti-gravity. Run it. Opening a web page. It's the web page with this cartoon, which I'll also put on the Moodle. Okay. So this has been put in the, I don't know, maybe it's like one of their programmer who found it very funny to put it, but it's in the standard library, but it's a nice example that things are very transparent. You can go to the location of the standard library, check what it's doing, how it's working, and then just use it, and things are crystal clear how they work. Okay? I like this cartoon. Good. So I hope I just gave you the will to go and look for yourself. There are many. I just gave you a very, very small insight of the stuff that are in the standard library and your ability to just go and check it for yourself. So I hope you will play with it a bit. And now let's take a 10-minute break, and then I will show you. So you remember I said that there are several ways to import modules. The last way is by installing modules that do not come by default with Python. They don't come with the standard library. One of the examples is NumPy, but SciPy is another. It's very basic library which everybody uses. Okay, they are not specific to astrophysics or to biophysics. Everybody uses them. And after the break, I will give you a small insight of what you can do with NumPy. Okay, so it's now 14. So let's resume at 25 past. Okay, for 20 minutes.
So when are we returning? 25?
125. I'll show you for 20 minutes what you can do with NumPy, and then we will end at 1:45.
אוקיי, אז שוב אנחנו למדנו ספריות, נכון? כאילו...
כן, אפשר לקרוא לזה ספרות, למדנו מודולס, כן. מודולס library.
כאילו, פחות הבנתי השיעור, אבל...
זה לא בדיוק ספריות, כי ספרייה זה ספרייה עם הרבה, זה כמו ספרייה עם ספרים, שכל ספר זה מודול. ספרייה זה סט של מודול.
אוקיי, וכאילו מקביל למחלקות, נכון?
מה זה מחלקות?
בג'אווה נגיד יש מחלקות שאפשר לרשום בהם כל מיני דברים, נגיד פעולות, ואז במיין, אני חושב שזה מחלקה, אפשר לקרוא לפעולות האלה, נגיד יש לי מחלקה בשם סטודנט שעושה איזה משהו, אני יכול לרשום סטודנט נקודה משהו.
כן, נשמע לי שזה המקבילה.
אוקיי. פשוט הראת, ואפשר כמובן לרשום שם פעולות במיין, אבל איפה שאת הראת, ראיתי שרשמת פעולה שנקראת find index או משהו, האם זה פעולה שנכללה ב...
זו פעולה שהיא כתבה מראש וסתם השתמשה בה.
לא, כי היא כתבה את זה...
כתבתי בה במודול. כתבתי אותה במודול. רציתי להראות לכם שבמודול אתם יכולים לעשות כמה דברים. אתם יכולים להריץ קוד, למשל print hello world, ואתם יכולים גם להגדיר variables, להגדיר פונקציות, ואתם יכולים לשלוף מהמודולים האלה את הפונקציות ואת ה-variable האלה.
הבנתי, אז כאילו יש לך פונקציה של ה-find index באיזה מודול, אז את עושה find index נקודה course.
לא, אני עושה my module נקודה find index.
אוקיי.
בסדר?
ואת צריכה כאילו לרשום בתחילת הקוד import
my module.
אוקיי. ולא נגיד import find index.
לא, אבל אתה יכול להגיד from my module import find index.
הבנתי.
אבל אז הוא רק ימצא לך את find index, הוא לא יגדיר את כל הדברים האחרים שאתה עושה.
אוקיי, רגע, אז my module נקודה find index נקודה נגיד courses?
אם הגדרת variable שקוראים לו courses שהוא בתוך find index, אז כן.
אוקיי, אז צריך להיות בתוך המשתנה הזה, צריך נגיד כמו בטסט, שזה היה צריך להיות בתוך בתוך המודול, בתוך הפעולה.
מה השאלה?
כאילו,
תחזור על השאלה.
היה את המשתנה הזה של הטסט, או טסט.
כן.
הוא היה בתוך המודול.
בתוך המודול. אז אם אני רוצה לשלוף אותו, אני עושה my module נקודה טסט. ואם הגדרתי אותו בתוך הפונקציה, אז אני אעשה my module נקודה פונקציה נקודה טסט.
אוקיי.
אתה מבין?
כן, פשוט מבלבל אותי, כי אם את רוצה נגיד ללכת למודול אחר ולקרוא לפעולה הזאת, אז...
נכון, אבל זה בדיוק העניין שאני צריכה רגע לעשות הפסקה קטנה, אבל יכול להיות לך טסט שמוגדר בהרבה מודולים, ולכן זה לא מספיק להגיד אימפורט טסט, אתה צריך להגיד לפייתון מאיפה אתה שולף את זה. להגיד אימפורט או להגיד טסט 2 שווה למי מודול נקודה טסט, ואז הוא יודע שהוא שולף את טסט ממי מודול, או להגדיר לו מראש from my module import test, ואז הוא יודע שהוא צריך לחפש את טסט בתוך my module. אני אראה לכם בתחילת השיעור, אני אראה לכם איך זה רשום בנוטס, ויש את כל הדוגמאות, כל בסדר?
בעמוד נקודה...
שאני חייבת הפסקה, בסדר? תזכור מה רצית לשאול.
וואו, 28 מעלות היום.
כן. להרצליה. אבל כן.
כן. מרגיש כמו 28. אני תמיד בודק את המרגיש כמו.
אני פשוט יוצא ומרגיש.
תל אביב.
אתה לא צריך טמפרטורה מדויקת. חם אז חם, לא חם אז לא חם.
לא יודע, תמיד או יותר חם או יותר חם ממה שאתה חושב.
אז צא ותרגיש.
בטאפוס.
כי זה לא מעניין אותי כמה אומרים שחם. אני לפעמים מרגיש פחות חם מאחרים, לפעמים יותר.
וואי, לא קר לכם?
לא.
תגידו את האמת. תגידו לי שלא קר.
אז לגבי המוד...
אני רוצה רגע להראות לך. בנוטס in case, I hope that all of you already checked the notes, but in case you didn't, the notes of the code of the course, they come like this. It's a code that you can execute and you can edit, obviously. Okay, and this covers all your questions. So you see, it's the explanations are as comments, and you can execute this, and it will show you all the ways to import a module, to import a variable, a function. Okay, all the things that I showed are done in the notes, and you can run the notes and make sure that you understand how it works.
אוקיי.
Okay? You're welcome to ask me, but just be aware that everything that I write in the terminal is also in the notes.
No.
Okay, so so we have a little more sugar and then we continue. Okay. So we spoke about how to write your own module, and we spoke about all the modules that are installed by default and have already been written by others. We saw that there are many useful things, less useful things like this anti-gravity thing, which is just funny. Okay? And now we will talk about some of the libraries that are the bread and the butter and bread and butter, I don't know, makes sense in English, of our work in Python, but they don't come as a default library with Python. You have to install them, and it's very easy to install stuff in Python. Usually you do it with pip install, at least in Linux and Mac. Very easy to install, but you need to do it actively, okay? And if you haven't yet, you should do it as soon as possible, because this is really the base. So, okay, so we will start with a library called NumPy, which is basically the library that allows us to manipulate arrays, okay? There is a way to do it without NumPy, but it's less efficient. There is a very good reason why some very clever folks in California made this library because the default way in Python is not so efficient. Okay, so it's an array language. We will talk about, I will give you examples. So a few important things. Where are my notes? When you work with NumPy array, so yeah, I told you that NumPy is mostly written in C, so it's inheriting from the efficiency of C. Operations are done element-wise. This is an important difference from other languages. So if you add two arrays, the elements will be added element-wise. Okay, same for multiplication. There are some so arrays are not lists. There are all kind of bonus features which I will show you. For example, you can have arrays of booleans that are very useful. And this is just to remind you that what I will show you now is the very basics, but there are loads and loads of reference online on all the capabilities of NumPy. It's something that you need for your research more than just the very basics, then there are loads and loads of resources. So let's start. I will show you a few examples in the presentation, and then we will give it a try. Okay, so the way to use NumPy, you do import NumPy. Usually NumPy is too long. We don't have to write NumPy every time we call a function from NumPy, so we call it as NP. Okay, and here we're just initializing an array. We're just defining an array. Okay. So this is a 1D array. This is a 2D array. You see, this is like a matrix, basically. Okay, and then there are all kinds of functions which have been written inside NumPy, which you can call and use. So, for example, the shape function. If you do np.shape of A, it will give you the shape of this 1D array. The shape of the 2D area, you see. Okay, you can index the shape is returning a tuple. This is a tuple. Remember we talked about the distinction between a tuple and a list. So you can index the shape. The first element of this tuple is 2, the second is 3. Okay, so it's a 2 by 3 matrix, this, which means it's 2 lines and 3 columns. Okay, make sense? Okay, so Pythons are not list. NumPy arrays are not list, and I will show you an example of this. But so this is a short example of why we should really use arrays, NumPy arrays, and not the lists that are defined by default in Python. Okay, so one of the reasons is that you can use conditions inside your arrays. I will show you an example. And so this is basically the same operation, which is executed once with NumPy array and once with a list. Okay, I have a big array with 100 random numbers. Okay, and I want to print only the numbers that are higher than a certain value and smaller than a certain value. So you see how compact it is to write it in NumPy, and this operation takes 0.2 seconds. And if I wanted to do this very same operation with a list, okay, and so I will define a list and do a loop, ask it to loop through the list and make a list of the elements that fit this condition, and this takes much longer. Okay, so this is one example where NumPy is
לא
much.
צריך לולאה בשביל
מה?
לא צריך לולאה בשביל זה, כאילו אמור להדפיס.
זה?
כן.
זהו שלא. NumPy נותן לך את האפשרות. Ariel asked if we don't need a loop, and the answer is no. In NumPy, you can use this syntax that gives you a
But
Boolean
there is a
array.
difference here. In the first one, A gets the whole 100 numbers. In the second one, B only adds the numbers that answer the question, like if x bigger than 0.6 or x smaller than 0.2.
No, because A of this is only giving you the
Yeah,
value of A where this is true.
That's what it prints. But in terms of memory space, this one saves more numbers compared to this one.
Maybe in terms of memory, but at the end, this is a shorter array than A. A where a condition is defined is shorter than
never mind. I just realized what I missed.
This is an array of Boolean which has false values and true values, and when you take A of this Boolean array, it gives you the values of A where they are true. Okay, so we'll give it a try. אוקיי.
אז את בעצם מדפיס כל המספרים במערך
עוד מעט ננסה את זה ואתם תראו מה זה עושה.
כאילו יותר גדולים מ-0.6 או יותר קטנים מ-0.6?
כן.
אוקיי.
Okay, there are all kind of useful NumPy functions. For example, if we want a diagonal matrix, there is a function that does it. If we want to initialize a matrix with only zeros, this is a very, very useful function if we want ones. Okay, so these are just a few examples. And this is the way to initialize an array. So you have several ways. If you want to, if for some reason you need your array to be defined in advance before you populate it in your code. So one way is to fill it with zeros, but it's not necessarily the good way, because maybe you will want to populate it also with zeros, and you will want to have a way to differentiate between the zeros that you put and the zeros that were just there when you initialize. So one way is to define an empty array, okay, that just allocates some memory for an array of a certain size, and usually you will want to add this here, because otherwise it will force the type of what you will put in your array. So this is the broadest way to initialize an array, where the object is not constraining you in terms of the types of the object. If you want your array to have strings and numbers and booleans, this is the best way to initialize. It's not constraining the type. Okay? And there is another very, very useful command for research, for your for anything you will want to do. If you have a data file, okay, where this is the content of the file, and you want to load this file into your code, you want to read the file. Okay, so the command is this gen from text. It's like generate from a text file. Okay, this is one way. You will see when we talk about the Panda library that Panda is actually better to use for handling large data files, but this is one way. Okay, I've used it for years before Panda became popular, and it's a good way. Okay, so now
מה זה עושה? מכניס את המספר?
זה קורא את הפייל הזה. So here you would put the name of the file inside the parentheses. Okay, let's say that this is the content of a file called text. Okay, so here you would put a string with the name of the file, and it reads your file into a big matrix where these are the lines and these are the columns.
Okay.
Just load the data into an array. Okay, makes sense? So let's.
Does it also work with Excel?
Yes, if you have in all your Excel lines the same number of columns, and if you don't have missing columns, missing lines, at the end, Excel is just an editor for a text file. You can read it as a text file, as a CSV file.
CSV.
Yes.
Because
And-
in MATLAB it's strictly like that.
Right, but you don't have to do anything to. I don't know what happens if you just gen from text and Excel directly. I don't know. I think Excel is a bit overrated in research,
Yes,
but
of course.
that would be a question to Google, and otherwise you just convert it into CSV. And,
Yes.
Okay, so in the last 5 minutes, I want to give you show you examples, and you're welcome to practice too. Okay, so I'm importing NumPy as NP.
How do we download it so we can use it?
Sorry.
How do we download it so we can use it? Because currently we don't. Mod.
So you have Windows.
Yes.
So you ask Google how to install NumPy in Windows.
But if you have PyCharm, it's directly from there.
You're using Python?
Yeah, but it doesn't seem to have it.
If it writes error, just click on download. There's supposed to be something.
Okay, so in the meantime, I'll show you a few commands, okay, and they are from the notes, so you can also look at the note. Okay, there is a function called arrange.
צריך להוריד נמפאי?
כן, זה מה שאמרתי, שנמפאי הוא לא מוגדר בסטנדרט לייברי שמגיע עם פייתון, אתה צריך להתקין את נמפאי. Okay, so let's see what arrange is doing. This arrange is very, very useful. Okay, so arrange is 0 to 10 with increments of 1. Okay, so if I put 2 here, okay, okay, so it's making a list of numbers, okay, okay, now let me show you if we do it with a range or with a list. Let's give it a try.
למה אבל שזה דווקא את המספרים?
Arrange is a function which is defined in the NumPy module. Okay, just like find index, we defined find index in my first module. So there is a function in NumPy, in the NumPy module called arrange, which prints for you a list of numbers from 0 to 10 spaced by 2. You can put here 0 to 100 spaced by 3. You can, okay, but you don't have to do it again. Now, you could do it with a list, but it would take much longer. So let's show you the difference. You remember that, okay, I'm going to do a much longer one, and B is equal to the same. Okay, and I want to define C, which is A plus B, and print the time it took. Okay, and I need to import time. Import time. Okay, so with NumPy, it took 0.12 seconds to do this operation, to add 2 arrays of 1 billion numbers. Okay? Now, if we had to do it with a list, okay, so I remind you that there is, you don't need NumPy to do this range thing. Okay, this A and B are lists. Okay, and if I had to do it without NumPy, I would do C equal empty, and then I would do a loop for I in range of len A.
בטווח בין 0 ל-10 זה אמור להדפיס כאילו 0, 2, 4, 6, 8 ו-10?
לא, תזכור שזה לא מדפיס את המספר האחרון.
אתה רואה זה מדפיס עד 8? כן.
Okay, it took 3 seconds to do the same without NumPy. Okay? So I'm showing you the difference between our NP arrange and just the Python command range. Okay, it's doing basically the same. Okay, it's printing it in a weird way, but range and arrange are giving you the same thing, but doing operation with the NumPy arrange one is much faster. Okay, it took 0.2 seconds with NumPy and it's taking 3 seconds without it. So just use NumPy for all the things that are array related. Okay. Now let's try this Boolean file that David you asked about. So I'm going to define an array with random numbers.
כשאת עושה import time זה כאילו ידפיס לך אוטומטית את הזמן שלוקח?
כן. זה לא ידפיס לי, זה... אני צריכה לעשות ti שווה ל-time.time ואז זה, ואז...
לא ראיתי שעשית את זה.
כן, עשיתי את זה. Okay, so now I want to print a higher than 0.6 or smaller than 0.4. Okay. So David, this is an important one. So this will print me an array of booleans. Okay, and the moment if I do a of this boolean, it will only print the places where this is true. Too many indices. Okay, so I can ask it to select the values of an array where a condition is verified. This is a very useful one. Okay, and I showed you the shape one, I showed you the len one, and I'll just show you that things are working element-wise, and then we will stop. So if I have b equal to this, so a times b, it's not a matrix multiplication, it's an element-wise multiplication. Okay, it's important. So it's hard to see without printing A and B, but this is important that things are done element-wise, and if you want to do a matrix multiplication, I think it's points times stars, but it's the default is that operations are made element-wise. Okay? Hmm? Maybe the dot, yes. Yes, right. Okay, there is a package called np-linalg, which does all the linear algebra, basic linear algebra of matrix, which is very useful. And
Also finding eigenvalues.
What?
Also finding like eigenvalues.
yes.
Wow.
Linalg is doing all the linear algebra on matrix. You don't have to reinvent it. This is the beauty. And okay, I showed you how to initialize stuff. And there is also a function called np-sort. This is the last thing I will show you. np-sort is sorting the values of an array, and np-argsort is returning the indexes of the sorted array. Okay? So, two very, very useful functions of NP, which have been optimized in C, and you don't have to worry about them anymore. Okay, and this was also just a small insight. There are plenty of NumPy commands, but the ones defined in the notes are the ones that we want you to know. Okay, sort, argsort, the ways to initialize. These are stuff that we can ask you about during the exam. Okay, generally speaking, all the commands that are in the notes, we expect you to know or to quickly have in mind. And beyond this, we don't expect you. We expect you to be able to recover stuff beyond them with Google, but not to know them. Okay?
מתי הבחינה?
בשבוע של נראה לי שזה בשלישי, זה הכל רשום במודל.
בתומקס יהיה כמו עננה בחום הזה, כאילו אזור לתפריט.
מה זה?
בתומקס, במבחן, זה יהיה נטו כמו מסמך וורד, או שיהיה סביבת עבודה.
זה יהיה כמו מסמך וורד. אבל זה עם חומר פתוח. אבל אתם לא תספיקו אם לא תדעו את הקומנט. אבל לא תוכלו להריץ את זה בשביל לבדוק אם זה רץ. אז זה בשלישי נדמה לי, רשום במודל.
צריך להוריד תומקס למחשב או משהו?
עשיתם כבר בחינות בתומקס?
לא.
אני חושבת שצריך, כן, צריך להוריד משהו שמשתלט לכם על המחשב בזמן של הבחינה בשביל שלא תהיה גישה לאינטרנט בגדול. נדמה לי שזה בשלישי, אבל...
בשביל הפעמים שהלכתם היה כתוב ב5 ל6. 5/6? אז זה ב5/6. זה כתוב במייל.
אם זה בתאריך שכתבנו לכם, זה לא... בסדר? So we finished for today. You had a question?
Yes. You said that by using the NP4, it just makes an array we can make this out the NumPy library, right?
By using what?
If I'm making an array from the NumPy library,
Yes.
then it's like I'm making this out the NumPy, just faster.
Right.
What's the difference? I mean, when I'm making like a plus b from the NumPy, how does it know to do that element-wise? While if I'm doing it without the NumPy, it won't.
So the people who wrote NumPy wrote it in a way that it's element-wise. they wrote it in C in a way that Python, whenever you call NumPy, is running
But when I'm doing
the
just
module?
A plus B, does it know that A and B are made from the NumPy library?
yes.
פלוס B עוד פעם הקטע של ה-A כפול B, ה-A ועוד B לא...
תראה, אני אראה לך דוגמה.
זה כאילו מדפיס לך אבל מה שאני חושב עכשיו את ה...
אני רוצה להראות לך מה זה עושה ה-A.
מה נמצא בזה? סבבה, אני מכיר את זה. אני יכול
A
לסתכל.
times B.
A שווה 1 פלוס 1, וגם A שווה ל-2 פלוס 0, אותו דבר.
ברגע שאתה מגדיר את A ו-B בתור NumPy arrays, אז הוא, בוא נראה, print type A, okay, the type is a NumPy array, and so when you ask it to do A plus B, it's understanding that it's doing an operation between two NumPy arrays, in the same way that if you add two strings, Python knows that you put them side by side, and if you multiply a string by 2, it will, you know what I mean? So it's understanding that it needs to do the operation between two NumPy arrays, which is defined in a certain way. Okay, so Ariel, you see that A plus B is doing it element-wise, print A ו-print B. אתה רואה זה A זה B, אז A פלוס B הוא עושה 0 ועוד 0, 1 ועוד 1, 2 ועוד 2, אתה מבין?
אוקיי.
זה כאילו האובייוס, אבל הכפול הוא עושה 0 כפול 0, 1 כפול 1, 2 כפול 2, 3 כפול 3, הוא עושה את זה על כל מיקום, את המכפלה. זה יותר חשוב לזכור את זה כשיש לך מטריצות, כי הרי יש אופרציה באלגברה לינארית של מכפלת מטריצות, שזה לא מכפלה element wise. אז צריך לדעת שהמולטיפליי פה זה element wise, זה לא מכפלה מטריצות.
אוקיי, היה איזה פעולה שמחקת אותה? אבל הרנדום הזה הוא מריד, כאילו מדפיס 10 מספרים רנדומליים?
הרנדום לא הראיתי את זה בהקשר של NumPy, הראיתי את זה בהקשר של הסטנדרט לייברי.
לא, NumPy רנדום.
נכון. כן, נכון. NumPy רנדום, הוא עושה משהו, הוא עושה כמו רנדום של הלייברי, הסטנדרט לייברי, הוא פשוט נותן לך מערך רנדומלי עם גודל מסוים, של מספרים בין 0 ל-1.
מספרים בין 0 ל-1, אז למה יש?
בוא נראה. בגלל זה אני רוצה שתנסו בזמן אמת. NumPy
אבל אם אני אנסה בזמן אמת אני לא אספיק כלום אני לא אבין כלום ואני לא אספיק כלום לכן אני רושם את זה במחבט.
כן, טוב, אז אם זה עובד לך יותר אז זה בסדר.
פשוט אני לא
לפעמים לנסות אז מבינים יותר.
כן, פשוט לא, אני לא מהיר על המחשב לכתוב אותו.
הנה, תראה. NumPy רנדום של 10 זה נותן לך מערך של 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 מספרים בין 0 ל-1. וזה אתה יכול גם בטח רוצה פה סוגריים, זה מערך בשני מימדים.
אז פשוט נותן מערך
עם מספרים רנדומליים בין 0 ל-1.
אוקיי, וזה כאילו NumPy ומה NumPy range עושה?
נותן לך מספרים בין שני המספרים הראשונים שנתת לו, בקפיצות של המספר השלישי.
הבנתי.
בסדר? אתה יכול, אם אתה נותן לו NP range זה פשוט יהיה בין 1 ל-10, ואם אתה נותן לו עוד מספר פה 0, נגיד מינוס 1, 2, אז זה יהיה בין מינוס 1 ל-10 בקפיצות של 2.
אבל זה לא הדפיס את ה-10. זה לא הדפיס את ה-10. אוקיי.
סבבה? Ouais,